We're going to start the section 5.1 about sequences. So let's look at an example of a sequence. So one example would be 2, 4, 8, 16, 32, 64, and so on. That's one example of a sequence. So a sequence is an ordered list. There's an order, so there's a first term, a second term, third term, and so forth, and it's just a list of numbers. So that list could be finite. So for example, AM, AM plus 1, AM plus 2, and it has some kind of final term, AN. This would be a finite sequence, or it could go on forever and be an infinite sequence. So AM, AM plus 1, the next term would be AM plus 2, so forth. This is an infinite sequence. So let's look at a sequence that's given by a formula. Let's start with, I'm going to define two sequences, A1, and they're both going to be infinite sequences, and B2, B3, B4 by the following formulas. So AK will be given by K over K plus 1 for every integer that's greater than or equal to 1. And BI will be I minus 1 over I for every integer I greater than or equal to 2. So what I want us to do is write out some of the terms of these sequences. So I'm going to make two columns. Let's start with the A sequence. Let's write A1. You just have to plug in 1 for K. You get 1 over 1 plus 1, or 1/2. What would A2 be? 2 over 3. A3. 3 over 4. And A4 would be 4 over 5. So those are the first four terms of the A sequence. Now let's look at the other sequence, B. Now here, look at your formula. You're not going to plug in 1. I start off by plugging in 2. So B2 would be 1/2. B3 would be 2/3. B4 would be 3/4. B5 would be 4/5. So if you look, you actually got the same sequence of numbers. So these two sequences are identical to each other. All right, now let's look at another example. Let's compute the first 6 terms of the sequence C0, C1, C2, defined as Cj will be -1 to the j for every integer j greater than or equal to 0. So again, we just have to plug in. Our sequence here starts at 0. It's my starting number. So I'm going to plug in 0 for J. You get 1. Plug in 1 for J to get C1. -1. C2. It would be +1. C3 would be -1. C4 would be +1. C5 would be -1. So those are the first 6 terms in my sequence. You could write them in a list: 1, -1, 1, -1, 1, -1. All right, so now let's do something a little bit different. Let's try to find a formula for a sequence. So let's find an explicit formula for a sequence with the following initial terms. So 1, -1/4, +1/9, -1/16, 1/25, -1/36. So this 1 would be our first term. I'm going to call it A1, A2. Well, before I do that, let's notice some patterns. So the first thing I see is that the terms flip signs, right? Positive, negative, positive, negative, positive, negative. So it's alternating signs. And also, if I look at the denominators, what kind of pattern do I see? 4, 9, 16, 25, 36. Those are all perfect squares, right? So I can think about 1 as being 1/1 squared. 4 is 2 squared. 9 is 3 squared. 1/4 squared. 1/5 squared. -1/6 squared. So now I'm going to label this first term as A1. This one is A2, A3, A4, A5, and A6. So it looks like the denominator, in general, AK, the denominator would be K squared. Now, for the numerator, it's always either 1 or -1. So because it's alternating signs, it's either going to have -1 to the K plus 1 or -1 to the K. And it just depends which one of these is the correct sign. So if I plug in 1, looking over here, at my first term, if I plug in 1, I want it to be positive. If you plug in 1 into this one, it'll be negative. So this is the one, when I plug in 1 into it, it would be -1 squared is +1. So in my formula, I'm going to have -1 to the K plus 1. And this is my formula for that sequence.